My name is Max Erdic. I'm a distinguished engineer, part of the data centers business unit at Cisco. I'll let you introduce yourself.
My name is Lucas Kradiger. I'm working as the same group with Max.
Yes.
As one of his peers.
No, you're not a peer, you are my boss.
But, no, okay, I'm not your boss, but your boss is somebody else.
It's a common boss.
Yes, common boss.
So actually this session is a perfect segue for what we just saw at the end of the previous session. What
was it about? Secure group tags.
Secure group tags, right? So you will see what we're going to talk about today is how to secure interconnection, to secure interconnecting heterogeneous fabrics, data center fabrics, but not only data center fabrics. And we're going to bring up a couple of new, the agenda is kind of animated, a couple of new functionality that we're going to introduce in the next 3 to 6 months in our NXOS code, right, for Nexus 9000 platform. One is called the ACI Border Gateway, and we will clarify what the ACI Border Gateway is and why we went through the trouble of creating the ACI Border Gateway. And that, coupled with the VXLAN Group Policy Option, GPO, will clarify what GPO is, and you will see it's very, very, very similar to the concept of SGT that were just presented to you. The two functionality glued together or bound together will give us this secure heterogeneous interconnection of fabrics. Okay, that's the plan. So we have.
Can I go and sit down?
No. You want to say something there?
You go ahead. I'll jump in.
Okay, you can jump in. So first component is the ACI Border Gateway. So I don't know how many of you are familiar with the term border gateway. I mean, in the industry we have gateway for years. We have been having gateways for years for many different functions. When we talk about building data center fabric, we can all agree that the de facto standard has become to use VXLAN EVPN as a technology, right, to build the fabric. And what we usually say is that we allow you to build, even with an NXOS, very large fabrics with a lot of leaf connected to the same set of spines, right? But the fact that we allow you to build these gigantic data centers doesn't mean, or single fabric, doesn't mean that it's something that the customer should do, okay? And then what we always pitch is the power of actually building smaller blocks, smaller networks, smaller, I don't know if this thing works, but okay, smaller leaf spine topologies, and interconnect them with a device which is called the border gateway, right? And this allows essentially to get the best of the two worlds, because I can still build a pretty large network that allows me to have layer 2 and layer 3 connectivity, but in a very controlled way through the use of these border gateways. Okay, and the border gateway is really the key device and component that allows to control what type of connectivity I want to establish between a leaf spine topology I have on the left and a leaf spine topology we have on the right. And we have been shipping an architecture like this called VXLAN multi-site and its counterpart on ACI called ACI multi-site for many years. You see here is 2017. ACI multi-site, I think it came in 2018, few months later. And these were homogeneous network option, right? So I could use border gateways for a VXLAN EVPN fabric to connect to a border gateway of another VXLAN EVPN fabric and extend my connectivity layer 2 and layer 3. Or I could do a border gateway, which is actually a spine for an ACI fabric, and interconnect with the spine of another ACI fabric and build an ACI multi-site domain, right? But only in an homogeneous fashion. What our customers have been asking us for years is that we would really like you guys to open up ACI, right, which has always been considered a kind of a closed option from a technology perspective, a closed fabric, to open up ACI and allow me to build an ACI fabric and a standard VXLAN EVPN fabric and make them part of the same multi-fabric domain, right? Then gives me the capability of starting with one approach and maybe evolving or growing my network following a different approach if needed be, right? And after a few years, we started listening, right? It takes some time. No, we listened from the beginning, but let's say we executed on this. And what we are introducing, actually, here I say second half calendar year 24, but you will see a first instantiation of this ACI border gateway earlier. We're going to introduce a border gateway function for an ACI fabric. And that border gateway, we will see in a second, it's working in a full standard VXLAN EVPN fashion, right, to interconnect with the VXLAN EVPN border gateway that already we have available for standard VXLAN EVPN fabrics. You get up, so it means you want to say
I'll
that.
add a couple of things because he always jumps right into the Cisco terms and the Cisco architecture piece, which is great.
Yes.
Efficient Italian. I haven't seen one that often.
We have 24 minutes. That's also bad.
Here we go.
Yes.
But when we roll a little bit back, when EVPN started, we had a lot of issues. One of it was actually there is no inter-AS option. Just doesn't exist or didn't exist then. So we had to come up with an approach to do the same thing what we did in MPLS, separating multiple networks and interconnect them with layer 3 VPN, or in this case, EVPN. So this gateway functionality Max is talking about is literally a better inter-AS option B, in the sense of better, it doesn't only do L3, it also does it for L2. And it's not that you need an additional labeled unicast approach or an LDP approach to do so. Given we use a tunnel as VXLAN is, we're literally just letting the control plane direct where the tunnel next hop is. So that was the origin of all these border gateway discussion or multi-site discussion, which we started doing around 2017.
I would like to ask is the rationale behind this change. That's one thing. And the other one is, when knowing how ACI operates, and usually the policies are applied inbound leave, so what's going to happen then for the policy application whenever you do this type of deployment? Because then the magic of the big brain on top of everything, well, has to be moved somewhere else.
Absolutely. For the second question, bear with us. There is a piece coming into addition to this.
Wonderful.
So that's where the fancy stuff come in. The first related question, I guess, is why not building one big fabric, and why not just doing it? The thing is, everything has resources. It's easy to say, hey, my table can do 1 million routes.
TCAM.
No, it's actually not TCAM, to be honest. It's more of how many sessions you actually can create. So every hardware platform or every chip needs also to have a little computer in there, which we call the control plane or the CPU, supervisor in other terms. The question is how powerful that supervisor in every switch needs to be, and how much you're willing to pay extra to make that as big as actually the TCAM or the ASICs can comprehend what is going there. So you have to have that balance. Now also, when you look at tables in an ASIC, it's not just one table and one number that counts, it becomes multidimensional. So let's say it's route, it's next hops, it's ECMP groups, it's. So there are tons of things. Very often we talk about abstracted numbers. I want to have 1 million route. Tell me how many ECMP paths you want for that 1 million route. It's 2 numbers. So when we give numbers, it's actually never really a hardware capable numbers. It's actually what the hardware in combination with software on a given switch can do, and in conjunction with other systems around. This said, we can do today somewhere north of 1,000 neighboring VTEPs. What's the magic number?
1053.
1053, magic number. But in what conjunction do the other systems also have to work in order to be able to communicate with the 1053 others? That's become the complex things. That's where you see networks often refer to 256 VTEPs or 256 leaf switches and so on and so forth. Now, in the case of what Max was just presenting as this architecture approach, we are hiding hundreds of VTEPs behind an abstraction layer, behind that gateway, so they're sitting behind. From the outside, you see 2 VTEPs. So you need to interconnect or interact with 2 VTEPs instead of 500s or hundreds there. So that's that abstraction or that hierarchical network approach.
So it's adding another level of indirection so that you don't have to then share all this topology information with the other side.
Exactly.
It can scale higher, but then it means that you have to handle the abstraction right in the middle. So what are the capabilities of the device right in the middle doing this? Yes. I am very sorry.
No, you're good. You're good.
I'm a decent freak, but
yeah, no, that's good. Thank you for being here. That abstraction layer in that middle, we started shipping in 2017 on all of our Nexus platforms. It runs at land rate. It's an ingress decision piece, so we're not adding recirculation or stuff in there. What we require is the gateway function, meaning we need to be able to terminate the tunnel and reoriginate a tunnel.
We'll see. We have a slide.
You have a slide
We're
on
gonna
it.
see that.
What we do with it, we basically use the BGP next hop attributes in order to decide where a tunnel stops or a tunnel goes.
Just like OTV when you had to put something into the
Oh,
interface so it comes out.
No. We're not. Let's not go there. But good.
Three word letters, right?
The Mickey Mouse design. That was the Mickey Mouse design. No, we're not.
We gotcha. But a little bit of background.
Are there any special requirements for the link between the two border gateway controllers?
Normally, there is no link between the border gateway controllers. These are like independent layer 3 devices, right?
Yeah.
Working in an anycast mode, right? So they're independent layer 3, which obviously have a control plane to determine, for example, if you need to extend layer 2, which one is in charge of flooding the BAM traffic, right? So they put the brain together through a control plane, but you normally don't need a link between them, except for the very special.
Yeah, but essence is it's a shared nothing approach.
Yeah, shared nothing.
These are two individual devices. They have individual personalities, so they have their own IP address, if you want so. Communication in between them is BGP.
Yeah.
It's BGP, EVPN as the address family there. What they share is what we call that anycast IP address, meaning in addition to the individual personality, we add a common IP address to that cluster set, if you want so, or that border gateway set, which makes them look from a data plane as one.
Yeah.
Control plane, multiple, data plane, one.
And this is basically a view, right? So basically they will share an anycast address, which we call the multi-site VIP, so that we basically, as Lucas was saying, we stitch 3 tunnels, right? Inside each fabric, from a leaf. Whenever I want to communicate with something on the other fabric, I go to the multi-site VIP or my local border gateways. The border gateways take the packet, the encapsulate is inspected, right? Do the layer 2 lookup, layer 3 lookup, whatever I need to do, and then encapsulate to the multi-site VIP of the border gateway where the destination is connected. How do I know where my destination is connected? I have and that's the previous slide, which I'm going to quickly show you. I have an MPBGP VPN control plane that runs between the border gateway of different fabrics, fully standard, that exchange type 2 and type 5 to exchange subnet and specific endpoint information, right?
So latency is no issue. Let's go crazy. I can go with one side Europe, one side Australia would
Absolutely,
work, yeah.
Absolutely. So two endpoint will talk layer 2 or layer 3, no matter if they're connected to the same switch or to two switches in the opposite side of the world. Technology is exactly the same, tunnel stitching, right? And one comment on the scalability consideration, I would say that this use of border gateway and building these different blocks, yes, scale benefits is the one that Lucas mentioned, but it's also from a networking perspective, is providing control of what connectivity you want to extend, right? You may not have in this fabric all the VLAN, all the subnet, you may not want to extend all of them to the other fabric, right? That level of control, you get it at the border gateway. And even for the subnet that you extend, you can control the amount of BAM traffic, broadcast, and non-unicast that you let out of your fabric. So if you have a broadcast storm that is here because of a bug, because of a loop locally created, you can ensure that the other data center or the other fabrics are not impacted.
Functioning mechanism is analogous to what the spine proxy does. You need to ask where to go, and the spine knows, but you don't necessarily know anything else. Yeah, purely the ACI lingo, but yeah. So, so then you don't necessarily need to know all the details. You know where mom is. So then go mom, and then she's gonna tell you where to go.
Correct. In reality, the border gateways will also inject inside the fabric the type 5 and type 2 information that they receive from the other side, but the next stop is the key, right? The next stop will be regenerated to be the multi-site VIP of the local gateway. So everything will come to me because I'm the gateway and I'm handling all the communication with the external world, okay? And the idea, as I said, is to have the same mechanism that we have between homogeneous fabrics, now also for heterogeneous, okay? Two more, because I see the clock, two more geeky points about interconnecting these domains. We want to be sure that we support adding fabrics that already are running to the same multi-site domain, which essentially means we need to be able to do what we call usually namespace normalization, or I want to be able to have a VNI, which is a subnet, right? Defined here, which has its own value. As you guys know, Epic gives a VNID to each bridge domain that you create, right? Based on its own internal logic, right? I may have VXLAN EVPN, a VXLAN EVPN domain here with multiple sites already up and running, where that VNI has been assigned a completely different value because it was assigned by different controller or manually or Ansible, whatever it is. But for me, that subnet needs to be the same, right? So how do I normalize things so that if I have an endpoint connected to L2VNI 10,000 here, can look like being connected to the same layer 2 domain of an endpoint connected to L2VNI 20,000, right? And there are a couple of options. If all the namespace is homogeneous on the VXLAN EVPN side and is only different on the ACI side, right? We can introduce a translation function on the ACI border gateways, right? So that they translate local resources value, like 10,000 in this example, the VNID, to 20,000, which is the remote value that matters, right? So there will be a control plane and data plane usage of that 20,000 VNID value, so that when I send traffic from an ACI fabric border gateway to a VXLAN EVPN fabric, I will use the value that means that subnet on the VXLAN side, so that when the fabric gets it, it's like, oh, I need to do the lookup in the VNI 20,000 and allows that layer 2 connectivity. The exact same thing will work for layer 3, right? Layer 3 VNI are assigned to VRF. So if I want to extend only layer 3 connectivity with the VRF, I will do the same thing, right? So it's a way to do namespace normalization with this translation only happening on one side, which is the ACI border gateway. It's the only one that needs to do the work and know how to translate what to what, okay? Now, the little bit more complex case is where my namespace on the VXLAN EVPN side is also heterogeneous, meaning VNI 20,000 and 30,000 are supposed to mean the same layer 2 domain with 10,000 here, right? Now, if I do the same approach that I showed you in the previous slide, this border gateway now would have to do two translations, 10,000 to 20,000 and 10,000 to 30,000, right? So it has to do double work on this side to be able to talk to both. If I add more fabrics, I need to add more translation on this side, right? So it may become a bottleneck, right, from that perspective, which is the reason why we're looking into implementing a different model for that, which basically calls for the need of performing the translation on all the border gateway on all the sites, and using a common, if you want to call it a stepping stone VNI, right, in this example, 50,000, so that all the traffic that leaves my ACI fabric is going to be sent as if it was belonging to that 50,000 value.
So this is analogous to a transit VLAN.
It's a transit VLAN. It's a transit VNI.
VNI.
It's a transit VNI. We don't reinvent. We reuse the smart thing that we've done in the past, right? So, and this will obviously give you more distribution because every border gateway in my example has to do one translation in this case, right? Instead of having to do two on one side, right? So we'll give you both capability, and then this makes more sense when you have a complete heterogeneous scenario.
And the border gateways, I just need to configure this one time. It's distributed, or I have to take care of the config of each one?
The border gateways, each border gateway is configured independently because you want to have control of what you extend in and out of a given fabric. Right? Obviously, we'll give you, tools. You will have tools because this is standard thing. You can use Terraform, Ansible, you can use whatever automation you want to configure the different border gateways. The goal is also to give you the level of control I said, where if you want this L2 to be only extended between site 1 and 2 and not 3, that's how you control it, by configuring the border gateway differently, right? Now, NDFC could also do it. You select all the border gateways, say that VLAN needs to go, and boom, you configure all of them at once. That's an automation. It's a tooling discussion more than a technology discussion.
I mean, to the point you mentioned in regards of, I should not screw up my mappings. Could we do a distribution protocol across all of them to make it automatically? Yes, of course, but
It's too complex.
it will be super complex, and we want to keep them as independent. If from an ACI fabric sends an EVPN route over to an EVPN fabric, it has to be standard space, common understanding. We don't want to put piggyback things on top that creates some translation assumption or whatever else.
You'll be doing something like NAT 444. You can, I don't know.
Oh, yeah. I mean, we can do BGP NAT if you want, or whatever else. Yeah.
Then it would even become more complex. Assume it exists. Yes. Then you would have this question of, do you want it to be stateful or stateless? Where do you want to add the tag when not? And it just opens a kind of worms that gets awfully complicated.
Correct. We want to have the route targets to define what you import, what you export. We want to have the VRF definition, what defines what your VNI is. Is it a MAC VRF or is it an IP VRF? want to make sure that BGP and EVPN is the transport and no special fields are being used in that, which means ultimately, whatever gateway is on the other side, which is a VXLAN EVPN speaker, can talk to that gateway. So it's not only what is inside, it's also what is outside, can completely neutral speak based on a common defined language.
All right. So let's move to the next topic, because what we have been discussing up to now is extending connectivity, L2, L3 between heterogeneous fabric. But we want to do in a secure way, right? And then we go back to your question you had before and what you have seen in the previous session. So what we're going to introduce is this concept of this technology called VXLAN Group Policy Option, GPO, which is a way of basically providing secure group segmentation inside the VXLAN EVPN fabric, which is nothing new in the sense that with ACI we have been doing since 2013, right? We called it EPG at the beginning. Now we have ESG, which is actually the right way of doing segmentation in ACI. We are going to bring, this is part of a standard, and I'll talk about the standard in a second. We're going to bring a similar functionality. If you are familiar with ACI ESG, this is a similar functionality. It's a VRF-wide concept or grouping where you can basically create secure group inside the VRF and associate endpoints to that secure group, independently from which subnet, which VLAN they belongs to, right? So there is a full separation of the security and the connectivity, right? The connectivity, you need it. It's a network, it's a fabric, it's an interfabric. You need to be able to communicate. But to communicate in a secure way, you can build these groups and then apply security policies that could be called contracts, that are called contract in ACI. SGACL, secure group access list, are called here, but they're essentially the same concept, right?
Oh, don't. Then what happens, because these are heterogeneous environments, then where do you put then these policies, because they might differ? Do you need a common controller among all of them, or what do you do? Because otherwise then it's a mess. Then it might be permitting one side and then the other side is nonsense.
We'll get there.
We get there. Give me 6.5 more
Okay, I'll
minutes.
shut up.
No. These are very. The good thing is that we address the questions, so they're good questions, right? Very quickly, the two main use cases of GPOs. Well, one is, I already said, microsegmentation, the capability of creating groups and apply security policies, which is essentially ACL filters, right, between these groups, okay? And that's the use case number one, the obvious one that it comes. The other one is, and when I talk a lot with ACI customers, they tell me, oh, but it's very hard to do microsegmentation. I don't know how to microsegment. I just want to redirect everything to a firewall, right? For example, I want all my subnet to subnet communication to go to a firewall without doing the firewall as a default gateway. Well, that's where service chaining, and we have our colleague Kritika, who's the expert of service chaining in our group. Service chaining will be enhanced to use basically the grouping as a construct, right, to decide what to redirect to a firewall. So I create a contract and I say group 1 or group 100 in this example wants to communicate to group 200. They can never talk directly. I need to send the traffic to a firewall, for example, or a service chain that could be firewall load balancer or firewall IDS, IPS, whatever you want it, right? So it's essentially the policy-based redirection functionality that we have in ACI, right, apply to a standard VXLAN EVPN.
Why inspect one time if you can inspect 5 times? Yeah, so
the more, the merrier. One point about the standard, because these implementations follow the standard, and I want to make a point about this name. The first name you see there, M. Smith, Michael Smith, who is actually a distinguished engineer, still part of our team, is actually the man behind SGTs that you saw being presented in the previous session. He created SGTs back, 15 years ago, maybe 20. He's the man behind EPGs in ACI, ESGs, and obviously comes with no surprise that is as his name on this data plane. I have 5 minutes and 37, it tells me here. Okay. His name comes on top of this standard, right? Standard draft document, right? Draft Smith, which basically covers the first one, the data plane aspect. And you have seen it. I'm not going to repeat what you have already seen in the previous session. The grouping information is carried with the packet, right? The source grouping, and that allows them to apply policy at the leaf level. What we are doing here, we are not only enabling carrying grouping information in the packet, we are also marrying that with the second piece, which is a control plane. So I want to be able to leverage my EVPN control plane that I already have in my fabric, not only to communicate type 2 and type 5 network prefixes information, but also the grouping information of the specific endpoint that carries that MAC on IP address, right? So now, why is it important, right? And I think I have a slide. There is a slide for everything. Let me go there. Why is it important to use the MPBGP to exchange tags? Is because if you look at VXLAN EVPN fabric, when I connect my endpoints and I discover them, I exchange the information, right, type 2 normally, between the leaf. If I can carry also the policy information, not only I learn where the MAC and IP is connected in my fabric, or to a remote fabric if it is in a remote fabric, but I also learn is grouping information. What that allows me to do, it allows me to apply the policy always in the ingress leaf, right? It makes little sense to send a packet between Europe and Australia to drop it on a leaf in Australia, right? If I can drop it, if I know I want to drop it in Europe, right? And the ingress point in my multi-fabric domain.
So your source group, SGT at a point was called source group.
Yeah.
It's actually not anymore a source group.
It's
scalable
it's
security
scalable.
or security group.
Yeah.
Here, it can be a source group or a destination group, depending on what we apply. If we get the information over the control plane, it becomes basically a destination group. So we can make a decision based on the source, which is locally attached, the enforcement, which is happening local on the switch, on the ingress switch, to whatever destination we want to go. So traffic becomes much more optimal at that point.
Yeah. And if the policy is not just permit or drop traffic, but it's a policy that says I want to redirect, same story, right? I want to be able to redirect my traffic in the ingress leaf to the firewall service that I have available in my fabric before sending to the destination. Because if the firewall then drops it, I drop it right there, right? I don't send it to Australia to drop it on the firewall in Australia. Okay.
That's who you ask. If you ask an ISP person, maybe he prefers that, but yeah.
Because he wants to see the packet, why?
He can pay.
Oh, well, okay, well, that's a different discussion. Absolutely, absolutely. But if you look at the point of view of who pays.
But this is all tag-based stateless, yeah? So you can match the tag and then you do the decision on that, yeah?
Correct, exactly.
And maybe just for being very, very specific, we're not carrying the policy. We're carrying the group ID.
Yeah.
Right.
The policy is somewhere else.
Exactly. The policy is local,
Is the
right?
top-
The enforcement is in the tabs, which are
And they're
part
just
of that whole network.
slapping some color on top of the
Exactly.
frame. Well,
We-
the frame
we're-
that isn't built inside the packet.
It's a
whatever
level
it
of
be.
indirection, as you mentioned before.
Yes.
GPO is a level of indirection, so we don't have to use IPs anymore. We can group individual IP addresses instead of subnets or other kind of things. Saves a lot of TCAM, by the way, given that we had that conversation too. But the next piece is actually policy, right? And I heard the question is policy authoring and policy enforcement as an earlier question. And maybe you want to talk a little bit about that.
Last point I want to make on this is that it's still important to carry that source secure tag in the packet, because if for some reason I don't have the control plane information in the ingress policy, right, I can still apply the policy on the ingress leaf. That's the worst case scenario, right? I didn't get the update, or the table was clear. I send the packet to the destination leaf and then I apply the policy there. So carrying that secure tag is still very important in the data plane as well, but the control plane enhance the solution, right? Optimizing it. We have 1 minute and 10. So when you put together now, you see 1 + 1 does 2 or 3, if you want to be optimistic. When you put together the gateway, the ACI gateway to interconnect heterogeneous fabric with the GPO, now you can start building this solution where a secure group enforcement can be applied between endpoints connected to heterogeneous fabric. So I can have an endpoint to an ESG in an ACI fabric, group 1, that wants to communicate with an endpoint to a GPO group in a VXLAN EVPN fabric, and apply a policy, a contract between them. The policy authoring, here we have, and maybe you want to cover. I'll let you cover the point about that single point of management, please.
It always stumps me on this thing.
Yes.
So policy authoring is local to the domain. You make the decision where you want to enforce what. We can synchronize that different language which we have in ACI, different language which we have in NXOS, and give you a common enforcement set across the two. Max put it down there as, what do you call it? Single point of management. So you will see capabilities as part of our software suite, either in Nexus Dashboard or as Ansible Playbook, where you can talk to the individual controllers and create consistent authoring. When you want to add things like AlgoSec or Tufin or the like, we'll provide gateway and capabilities in order to make sure that your posturing is proper.